Now, a base can also be formed when magnesium oxide dissolves in water. When a metallic oxide dissolves in water, you can also get another type of base. The first one is metallic oxide, metal reacting with oxygen to give you metallic oxide, which is a base. Other ones are sodium oxide, lithium oxide, barium oxide, zinc oxide, lead oxide, aluminum oxide, iron oxide. All of them are bases. Now, when these oxides dissolve in water, they form another type of base called hydroxide, and they are called alkalis. Alkalis are soluble in water. So not all bases are alkalis, but all alkalis are bases, because not all metallic oxides dissolve in water or are soluble in water to give you an alkali. Only oxides of sodium, potassium, calcium, and at times, not all, magnesium. Magnesium oxide is sparingly soluble in water but soluble in steam, and so the hydroxide form is not all that soluble. Calcium is also soluble. Calcium oxide, which is already a base, all these are bases, their oxide are bases, is soluble in water. Potassium oxide is soluble in water because a base is a metallic oxide. Metallic oxides, when this metallic oxide dissolves in water, even though it's not all metallic oxide, it's only these few ones, when they dissolve in water, barium, lithium, also they are also soluble. Now, when this dissolves in water, you get an alkali directly, because Na plus, the oxygen and the hydrogen and the other oxygen combine to give you this. Just balance the equation by adding 2, because we have 2 sodium here, so we have 2 oxygen, 2 hydrogen, 2 oxygen, 2 hydrogen. Now, when a metallic oxide dissolves in water, you get an alkali. The same thing happens here, but in this case now, because OH carries -1 and calcium carries +2, because it's 20, atomic number is 22 on the first shell, 8 on the second shell, 8 on the third shell, and 2 on the last shell. It gives out 2. They exchange their valency. This is carrying 1. So what you will get will be calcium hydroxide. Instead of, in this case now, that you have potassium 19. Potassium is 2 on the first shell, 8 on the second shell, 8 on the third shell, 1 on the last shell, and OH here is minus. They cancel out because this is 1 and this 1 to give you potassium. And the same thing occur in sodium hydroxide. But in this case, this is what we're going to get. And in magnesium too, because magnesium carries +2 charge, then OH minus, you get magnesium hydroxide in this form. Now, magnesium hydroxide is only soluble in steam. This is soluble in warm water, so it's not all that completely soluble. All these are alkalis, and we call them strong base. This is an alkali, is a strong alkali, very, very strong, especially that of potassium. Now, calcium is a weak alkali. This at times can be classified as amphoteric, but at times as also a weak alkali. Now, so barium and lithium are not all that common, but they are also soluble in water. So only these metallic oxides are soluble in water. It means that some metals are not soluble in water. Don't forget, I define a base as a metallic oxide or hydroxide. Now, if that is the case, let's look at examples of those hydroxides that are not soluble in water. Copper oxide, lead oxide, they are also base. Aluminium oxide, this aluminium oxide. Aluminium has atomic number of 13. If you arrange it, you have 2, 8 on the last shell, 3. Oxygen can get or gain 2, because the atomic number is 8. 2 and 6 gains 2. That's why we have this. Now, all this and lots more. Zinc oxide, mercury oxide, lead oxide, and so on. All those ones, oxides of heavy metals, when they dissolve in water, they are not soluble. And if they react at all, they will end up giving an hydroxide also. But the hydroxide is amphoteric in nature. These hydroxides are amphoteric, that is, they behave like acid and also behave like a base. They are amphoteric, they behave like acid, two nature, they behave like acid and bases naturally. So they are amphoteric. In the presence of a strong base like sodium hydroxide, they will behave like an acid. In the presence of a strong acid, they will behave like a base. So not all oxides. So we call this amphoteric oxide because they are not soluble in water. They dissolve in water to form an amphoteric solution that behave like acid and base. Why these ones, magnesium, sodium, potassium, are soluble. Calcium, they are soluble. Now, this is a way of preparing a base. When a metal reacts with oxygen, a base is formed. Now, that's to form metallic oxide. Then a base can also be formed by reacting the metallic oxide in dissolving it in water to form alkalis, like sodium hydroxide, potassium hydroxide. Those ones are very soluble. And then the third way, this ones will form amphoteric. Now, the third way is by reacting a metal directly with cold water or steam, as the case may be. But the metals qualified for these are sodium, potassium first because it's the most reactive, followed by sodium, calcium, magnesium, etc. Now, iron only reacts with steam, and the iron too must be red hot to form. In fact, it will only form oxide. Oxides will be formed, and it will also liberate hydrogen gas. Now, the issue is that when you add cold water to potassium, because potassium is very, very reactive, sodium is very, very reactive, highly reactive, they give out 1 electrons easily. More reactive than aluminium, more reactive than copper, more reactive than lead and others. Calcium is still weak, group 2, but they are still more reactive than magnesium. They are still more reactive than other elements, but these are the most reactive, the fastest from this. Now, when you add cold water to these reactive metals, there will be evolution of a gas, like the bubbles that comes out from 7-Up. They will liberate hydrogen gas immediately, and an alkali will be formed, which is an hydroxide. So what happened here is that potassium is 19. You have K plus 1 because it gives out 1. This OH and A-. This combined with this, cancel out their valency, and then you have H left, which is written as H2. You don't write, hydrogen is diatomic. So in that case, just try to balance the equation by writing 2 here to make hydrogen 4. Write 2 here, 2 here. So when strong metals react with cold water, an alkali is formed and hydrogen gas is liberated. When sodium reacts with cold water, alkalis are also formed and hydrogen gas is liberated. The same thing occurs here, but in this case, calcium carries +2, H is +1, OH is -1. This comes together, exchange their valency. So you have Ca, 2 goes to the other side, OH, the 1 here comes here, which is invisible. The 2 goes to the other side. The 2 will affect oxygen and affect hydrogen. Then you have H left, which is written as H2. Hydrogen gas is also liberated, but this is a weak alkali, and 1 is invisible. The last one is with magnesium and is steam, while this is with warm water to liberate hydrogen gas. Now, for metals that are not reactive like copper, zinc, iron, lead, they are metals, they will not react with water. No reaction with water, even mercury or steam, whether steam or cold water or mercury or silver or tin or all those ones, they will not react with either steam or cold water. It's only that iron reacts with steam, and it must be red hot iron to form hydrogen gas, but an oxide will be formed instead. An oxide will be formed. The same thing with aluminium. Only an oxide will be formed instead. Now, this is just the difference between strong metals and weak metals. That's the strong metals dissolve in water like sodium, potassium, calcium. They dissolve in water to form alkalis and also liberate hydrogen gas. Why they are oxide? They are oxide dissolve in water to form alkali directly without liberating any. So in this way, a base is produced. A base. So there is a statement that says that all alkalis are bases, but not all bases are alkalis. It is true. that all alkalis are bases, but not all bases are alkalis.